Hello friends, welcome to this 5G series. So today we will discuss the NR channel structure and what are the changes in NR channel structure if we compare it with LTE. Okay, so let's see. Okay, so here what I will do, I will draw the downlink channel structure first, and I will draw like this that on left side I will draw LTE and on right side I will draw NR, so that it will be easy for you to compare what all changes are coming between from LTE to NR. Okay, so first we will draw the main transport channel. So as you know, upper one is the logical, transport, and physical, like this. So here we have, this is BCH, broadcast channel. Okay, so if we compare broadcast channel, we also have broadcast channel in NR. Good. So we have broadcast channel in NR as well. LT also, NR also. Then we have PCH. Okay. We have PCH in LTE and we have PCH in NR as well. So PCH stands for paging channel. Okay, so we have PCH in LTE and when we have PCH in NR as well. Okay, good. Now we have downlink shared channel, that is DLSCH. Sorry, DLSCH, downlink shared channel in LTE, and we have downlink shared channel in NR also. Okay, right. Now we have one more channel here in transport in LTE, that is MCH. Okay, multicast channel, but this channel we don't have in NR. We don't have this channel in NR. Okay, only 3 channels we have in NR in as a transport channel. This is PCH, BCH and DLCH, downlink shared channel. Now if we will see the logical channels, so these are transport channels. Now we will see the logical channels. What are differences? PCCH. PCCH is there in LTE. Okay, and PCCH is there in NR as well. Okay, now BCCH is there, broadcast control channel. This is paging control channel, this is broadcast control channel. This is in LTE. Now broadcast control channel is there in NR as well. Good. Okay, now CCCH, common control channel. Common control channel, that is in LTE. Now CCCH is common control channel is in NR also. Good. The next is DCCH, dedicated control channel, that is in LTE, and we have dedicated control channel in NR also. Good. Now we have DTCH. DTCH, dedicated traffic channel. Okay, dedicated traffic channel, and we have DTCH in LTE and we have DTCH in NR as well. I'll take it like this. DTCH in NR as well. Right, now we have here one more channel, MCCH, multicast control channel, and MTCH, multicast traffic channel. These we don't have in NR. Okay, so this is on logical channels. So logical channels we have this much PCCH, BCCH, this CCCH, DCCH and DTCH, but we don't have these two channels in NR, in logical channels if we compare. Now let's come out on the physical channel, that what are the differences in physical channel between LT and NR. So in LT we have PDCCH, that is physical downlink control channel, right? We do have PDCCH in NR as well, PDCCH, right? We do have in NR as well. We have PBCH, PBCH, right, in LTE, physical broadcast channel. And we have PBCH in NR as well. Okay, now what are the slight differences that I'll tell you later. First you understand that what all channels are there in LT and NR as compared to LT, what are channels in NR. Now we have PDSCH. This obviously this is the very important channel, downlink shared channel. So physical downlink shared channel this is, and obviously it has to be in NR as well, PDSCH. Okay, it contains various data and signaling. Now in downlink physical channels in NR we have only these three. Okay, in LT we do have three more channels, P, C, F, I, CH, a physical control format information channel, and PHICH, physical hybrid indication channel, and PMCH, physical multicast channel. So if I will mark now, okay, now I have drawn all channels what we have in. So if I will say that we do not have these channels in NR, we have these channels in LT but we don't have these red mark channels in NR. Okay, this is the difference between LT and NR logical channels, channel structure. So the uppermost is the logical channel, these are transport channel, these are physical channels. Now you know how they are mapped. I will show you mapping as well once. So this PCCH is mapped with paging channel, paging control channel is mapped with paging channel, and this paging channel is mapped with PDSCH. Okay, and here also it's same, PCCH is mapped with PCH and PCH is mapped with physical downlink shared channel, same. Okay, now BCCH, broadcast control channel, right, broadcast control channel here mapped with BCH, and BCH is for MIB, you know, and this is PBCH, this is mapped with PBCH. And here it is the same like LTE, it is mapped with BCH and BCH is mapped with PBCH. Okay, for MIB. So MIB, master information block, is transferred from here, like same in NR also, master information block is transferred from here, and this information, this channel, this logical channel is mapped with downlink shared channel also, and the SIB information, system information block, is transferred from here. Okay, and then it is mapped with this one, and the same is like this. MIB is transferred from BCH and SIB is transferred from here, like this. It is mapped. Now CCCH. So in CCCH, common control channel, it is mapped here again. Downlink shared channel, because it has many channels, control channels, and data information. That's why it is called shared channel. Okay. Now DCCH, and here also in LT in NR, CCCH is mapped with this one. DCCH is also mapped with downlink shared channel. Here also DCCH is mapped with downlink shared channel, and DTCH, dedicated traffic channel, is also mapped with downlink shared channel, right? And these two channels are also mapped in LTE with this downlink shared channel, and it is mapped with this also, right? And this is mapped with PMCH, but these red mark channels are not in LTE. So DTCH here is mapped with downlink shared channel. Okay, so this is the mapping of channels. Okay, now PDCCH, is for in LTE also, it is for downlink control information, DCI, and the same is here, DCI. So if we'll see, so we can say that these red mark channels are not present in downlink. As far as downlink channels are concerned, logical channels are concerned, channel structure, these red mark channels are not there. Some extra thing is there. If one thing I'll tell you, in LTE we have CSRS, channel state reference signal, and in LTE we have this channel state reference signal gets transmitted at a fixed interval of time and frequency. In PRB, if we will see, there is a fixed continuous transmission of CS. Continuous means after a particular RBs, there is a fixed pattern for transmission of CSRS, but it's not like that in NR, because NR is a lean, it is said to be the lean channel structure. Lean channel structure means because in NR we have the requirement of high data rate. So unnecessarily, like LTE, it gets transferred whether it is required or not, but it gets transferred at a particular interval. So to save that power, to save the bandwidth, to save the channel bandwidth, and power, and the space, PRBs, we have designed, the 3APP have designed the lean structure, lean, you can say lean carrier structure or lean PRB structure, so that there is no continuous transmission of CSRS. Okay, so to get rid of these, what we have designed here, we have got some extra channels, okay, in NR. And what are those extra channels? So I will draw that with green so that it would be easy for you to understand. Okay, so this PBCH contains PSS, SSS, and DMRS. So this DMRS is a new part here. If you will see, DMRS is demodulation reference signal. Okay, for every physical channel there is a DMRS, and what it does, it helps in demodulation. Right? It's a demodulation of the information that is carried by physical channels. So that is the main function of DMRS. Okay, so we can see, so including these three information, it is called SSB, that is called system synchronization block. That is called in NR, system synchronization block. It is the same information in MIB, here, but DMRS is not there. This one part is not there. It is the difference here, DMRS. So what more difference we have? That in PDSCH we have two more signals and reference signal, that is PTRS. This is phase tracking reference signal. Okay, this is the to track the phase noise. Suppose the phase noise is to optimize or to correct the phase noise, we have PTRS, phase tracking reference signal, and the DMRS for this PDSCH. Every physical channel, as I said, will have DMRS, so demodulation reference signal. Then this PDCCH will also have DMRS. Okay, and we do have few more channels, that is CSIRS, channel state indicator reference signal, and TRS. I mean, we can say that these two signals are of same kind of signals but at different time and frequency space. So you can understand we do have CSIRS and TRS is timing reference signal. Okay, so broadly if you will see, so these are logical channels, and the upper one is logical channels, channels. These are transport channels, these are physical channels, and these are reference signals and sync signals, reference and sync signals. So the difference, we can say that the red part is not present in NR, the red part, and the green part is present in NR, not in LTE. Okay, so this is the difference in downlink. Yeah, and if in uplink, let me show you the uplink as well. If we'll draw the uplink, LTE and NR. So uplink as such, there is no big difference, only DMRS is extra. In uplink we do have here CCCH, here also CCCH, we have CCCH, and DCCH we have, sorry, let me clear, CCCH we have here, CCCH we have here, DCCH, dedicated control channel, dedicated traffic channel we have here. Now dedicated control channel, dedicated traffic channel we have here. Then we have here uplink shared channel, right? We have here uplink shared channel as well, and physical channels we have PUSCH, we have PUSCH here as well, PUCCH here also, PUCCH here also we have, and we have here PRACH, one physical random access channel we have, and it is mapped with RACH. Okay, and this is uplink control information, UCI, and the same is here in NR, that we have a PRACH here, and this is RACH, random access channel. And as I said that every physical channel in NR will have a DMRS. So we have, so here the difference I will draw with green, it has DMRS, downlink, demodulation reference signal, and This one will not have the DMRS, PRACH will not have the DMRS, and this will have PTRS as well, phase tracking reference signal, and one SRS is sounding reference signal, right? Actually, this sounding reference signal is here also in you can say NLT. Okay, so these are the channels, and in uplink, so uplink as such, there is not much difference except this DMRS and PTRS. Uplink would be the same. Few things, few points I will also tell you that about this. What are the differences? The few main differences between LT and NR. That LT, if the hark is concerned, if we'll see the hark, right? So in LT we have asynchronous hark in downlink. Sorry. Yeah, and synchronous hark in uplink. In NR we have asynchronous hark both in downlink and uplink. And why it is required? It is required because of fast ACNAC, so that we won't be at any point of time we can send the ACNAC. We won't wait for the designated slot for sending the ACNAC. So that's why it is asynchronous hark in NR. So this also gives low latency in fast NR. And these DMRS, as I told you, the purpose of DMRS is that we don't have a fixed CSRS. Okay, we have DMRS. So whenever the physical channel will go, only then the demodulation reference signal will go. If there is no physical channel, unnecessarily, why we need to waste the bandwidth, why we need to waste the resources? So that's why, to save those resources, we have designed the NR like this. Okay, so hopefully this was, you will able to understand something, the differences between the channels between LT and NR. If somebody asks you, so you should be knowing it, that what are the differences. These are not present in NR, these red colors, and these green colors, except PSS and SSS are there, but DMRS and PTRS and these TRS are not there in LT. Okay, so that's it. So let's see some next topic we'll see in the next series, next lecture. So thank you guys.